Hello friends, welcome to our channel, that is Hariharan Express channel. Today another topic, that is rules of Boolean algebra. So how various rules apply for Boolean algebra with a certain logic gates. Okay, how different logic gates apply for rules of Boolean algebra. We will discuss that. Okay, so now we will start different rules, how it is implemented, how it is used for Boolean algebra. First, you see, very simple way I will explain all. Okay, suppose rule 1. Okay, so here is a very simple way, it is mentioned x plus 0 is equal to x. We have to prove it. X plus 0 is equal to 0. So here x plus 0 plus is equal to x. X plus 0 is equal to x. Here we prove that is the variable x and also use OR gate. Okay, and 0 is always equal to one kind another variable. Here x is one variable, 0 also another variable. Sum of that two variable is equal to x. Okay, now prove through that is OR gate. How OR gate it prove that is x. Okay, now take this OR gate, very simple way, all of you know that, very simple way OR gate we can take it. One part is x, another part is 0. Okay, one part is x, another part is 0. You see, you have to prove it, that is x or any other. Now you see, also we can take two values of x. So here x, another part is here 0, we will get two values. Then we have to prove it, what is the value of that, because here function is x, function is equal to x. Okay, what value we will get it here. Now we will start. If x is equal to 1, for example, x is equal to 1, that is a plus or plus 0, because this OR gate, that is 0. 1 plus 0 is equal to 1. So fx is equal to 1. Understand? So fx is equal to 1. X is equal to 1. Result also 1. That is a x. So what you get here, result will be x. What are the value of x? Same result we can get it, because here 1 plus 0. Okay, that means here we can write 1 plus 0, that is 1. 1 means x is 1, result also 1. Fx is equal to 1. So x, result is x. X plus 0 is x, where x is equal to 1. Suppose x is equal to 0, for example, x is 0. 0 plus 0, then what happens? So function x is equal to 0 plus 0 means what? 0. So x is 0, result also 0. So x also same, x value also 0. So whatever the value we consider for x, add with 0, result will be x. So we will consider OR gate in this way. So we consider OR gate to prove it. X plus 0 is equal to x. What are the value? We just prove two ways. One x is equal to 1, another x is equal to 0. 1 plus 0, that is 1, that is x. X value is same. Similarly, x plus x is 0. 0 plus 0, that is 0. X value also same, that is 0. So we prove it. Whatever the value of x, the result will be x. Okay, the first rule we consider. Next, second rule. Rule 2, we can consider rule 2. Rule 2 is x plus 1 is equal to 1. Okay, rule 2 is defined in this way, x plus 1 is equal to 1. Then what happens? Same case we consider OR gate. Since it is OR gate, we can take OR gate. Okay, two ways also we can consider, because two values we consider here. Okay, two values we consider. OR gate. So now we see one part is x, another part is 1. Here similarly x, another part is 1. Now you see, if it is 1, here is 0. For example, x is 0, x is 0, x 0, 0 plus 1, 0 plus 1 means 1. Okay, 0 plus 1 is equal to 1. Then here value we can get is 1. Okay, functional value is 1. So functional value will be 1, not any variable. Here is variable coming, but not variable, direct 1. Whatever the value of x, will see x is 0, value is 1. Similarly, if here x is equal to, here x is 0, here x is equal to 1, then x is equal to 1, 1 plus 1, that is 1. Okay, that is 1. So f is equal to 1. So whatever the x value, x is 0, x is 1, whatever the value of x, the result will be always 1. We consider this result will be 1. So there is no effect on this particular operation, value is 1. So not depend on x value. X value 0 we can consider, or 1 will consider, but result will be always 1. Since another variable value is 1, sum of two value is 1. So there is no effect on x. Okay. So it is very genuine way we can consider this particular category of logic gates, which is helped to evaluate this particular rule 2 x plus 1 is equal to 1. Okay. So now similarly different that is logic gates will apply, and different rules also we can analyze. Okay. Now we see another rule. Rule 3. Okay. Rule 3. What is the rule 3? We see that is no certain exactly sequence of rule, but rule we will consider. Okay. Previously what happens, we consider that is a OR gate. Here you see rule 3 very simple way, x dot 0 is equal to 0. Here we consider AND gate. Okay. Very simple way we consider AND gate. So now very simple AND gate, two AND gate we can consider, because variable that is there. Okay. One is x, another is 0. Here similarly x, another is 0. Okay. What the value we can consider. So here 0 and x, then we see if x is equal to 1, here is x is equal to 0, then we see what is the difference or same. 1 dot 0, that is 0, so value will be 0. Okay, what are the x value? Similarly, x is 0, 0 dot 0, value will be 0. Here function value will be 0, here function value will be also 0. So whatever the value of x and x, any value 1 0, x value 1 or x value 0, but there is no effect on this particular operation, that is x dot 0 is equal to 0. At least 1 is 0, definite whole product will be 0. Okay. So it is true, what is the value of x we can take, but the result will be 0, functional value will be 0. Okay. In this way, here we consider this AND gate. Similarly, if we go through another, one is x dot, another rule is there, that is x dot 1 is equal to x. We test it, actually it is 1 or any other, using that AND operator. So very simple, one AND operator, another, two times we will consider, because we test the different values of x. For the reason, two times we consider the value of x. Here is x, here is that is 1, another is 1, here is 1. Now test it. If x dot 1, Now x consider as 0, for example. 0 into 1. 0 into 1 means 0 into 1 means 0. So it will value is 0. So functional value is 0, and that is also x. If x is equal to 0, functional value is 0. So it depend on x. Okay, depend on x. Because if x 0, 0 into x value is 0. So x value also 0, output also 0, depend on x. Similarly, if we go through x is equal to 1, okay, here x is 0. If x is equal to 1, then here will be what? 1 into 1, that is 1. Okay, function value is 1, that is also x, depend on x, functional value also x. So what, whenever we will consider x is what is the value, okay, the result value also x, because x is 1, functional value is 1. So it is also equivalent to x. So what are the value of x, okay, we will consider, based on that x value we can get it. So x dot 1 is equal to x. So what are the value we can take it, also it affect on that value of x. So result also we can get like this, that is x. Okay. So these two that is AND gate or AND operation we will also consider, that is x dot 0 is equal to 0, x dot 1 is equal to x. Okay. Next also I will consider another way. Okay. So that part is important part also, we can see, that is 5, rule 5. Okay. That is x plus x is equal to x. You can prove it, x plus x is equal to x. Okay. So means what are the value of x we consider, same value we can get it, very simple. It is a OR gate, we can take it. Okay, OR gate. Okay, it is x, same x also we can take here and here, doesn't matter, we will prove it. Here also x, here also x. You see, first suppose x is equal to 0, for example, x is 0, 0 plus 0, okay, that is 0. So x is equal to 0, we get x is equal to 0, 0 value is 0, x is 0. So if it 2 value 0, so result also 0. So x plus x is equal to x, because 0 value put it, result also 0. So x plus x is equal to x. Here similarly, if x is equal to 1, that means 1 plus 1, that is a 1, x is equal to 1, result also 1. So we prove x is equal to 1 means result also 1. Okay, or function we can write, functional value also 1, in this way you can write. So x plus x is equal to x. What are the, whenever value change, x value, result also will change accordingly. Okay, so we can prove it through logic gates, x plus x is equal to x. Okay, now we see another concept. Now we see another concept, like rule 6. Okay, rule 6. Rule 6, that is x plus x complement is equal to 1. X plus x complement is equal to 1. Okay, that means the functional value is 1. That means functional value is 1. If x complement x, x plus x complement. Very simply we define, to OR gate we can take it. one is x, another is x complement. We can take also complement to another part, doesn't matter. We can take, doesn't matter. Here similarly x, here is a x complement. Okay, two ways we can take it. So now we just take it, x is equal to suppose 0. Okay, if it is 0, here is 0, here will be 1, complement is 1, 0 plus 1 is equal to 1. Okay, if x is equal to 0, value is 1. Okay, again test it. If x is equal to 1, you see it is 1, it is 0, so 1 plus 0 is equal to 1, so functional value is 1. So whatever the value of x we can take, but result is always 1. Okay, so whatever the value, x is 0, that is 1, x is 1, that is 1, whatever the value we can take, either 0 or 1, result will be 1. So x plus x complement is equal to 1, whatever these values we can take, that is true. X plus x complement, x plus x complement is equal to 1. Similarly, another part we can take. Okay, so another rule also we can take another way, like x, we can write a rule 7. Okay, x dot x is equal to x. Okay, x dot x is equal to x. How? You see, here AND gate we will consider. Same concept also define, same concept. One is x, another x we can take, no problem. X or here also we can define, no problem. Okay, here also, here x, here x. Actually two different, but here also put directly, doesn't matter. You see, if x is equal to 0, 0 into 0, that is a 0, so it is 0. Which one? X is 0, so output also 0. So f is equal to 0 here. Here f is equal to 1, here f is equal to 1. Okay, f is equal to 1. Here f is equal to 0. What are the, whenever x value 0, result also 0. Result 0 means x, that is x, because x is 0. If x is equal to 1, then you see result is also 1.1, that is 1, result also 1. So it is depend on x. Whenever x value will be changed, then result also will be changed. Whatever the value x, same value also we can get the as a result. X dot x is equal to x. Okay, so here also 1. So x value we can get like this. This is the basic concept regarding on this, x dot x is equal to x. Similarly, if you go through, that is another case, suppose 8. What is x plus, sorry, x dot x complement is equal to 0. Very simple way, because AND gate we will consider here. Okay, output also we define accordingly. Now we take two logic gates. Okay, one is the x, another is x complement. Here is the x complement. So what is the output? You see, if we consider x is equal to 0, then what happens? If it is 0, this is 1. So 0 into 1, because it is AND gate we consider. 0 into 1. 0 into 1 means 0. Okay. 0 we consider into 1, so 0. If it is 1, x is equal to 1. Here f is equal to 0. If x is equal to 1, then it is 1, it is 0. So 1 into 0 is equal to 0. So f will be 0. Here f will be 0. So whatever the x value we will consider, then result is always 0, because the complement is there with the product. Okay, since x is 0, what happens? X 0 means x complement is will be 1. then product of the 0 into 1 will be 0. So whatever the value, either 0 or 1 we will consider for 0. So automatically result also will be 0. There is no other option to change it. So x dot x complement is always 0. Okay. So this is the basic rules we will consider through, that is different logic gates. Okay. So other rules also there, we will prove it in other way. Okay, without logic gates also you have to prove it. That is no problem, because that rule depend on this above how many, that is 8. Okay, 8 number of rules. We apply this 8 number of rules in for different proofs. We will go through one after one. Let's see. Okay, so another rule apply, like rule 9. Okay, rule 9, that is x plus xy is equal to x. We will prove it based on that previous Boolean rule of Boolean algebra. We just apply those rules, we prove it. Okay, how we will prove, we will see. Now we have to prove it, x plus xy is equal to x. Very simple way. Now we prove it. Okay. Okay. So x plus xy is equal to x into 1 plus y. Okay, x into 1 plus y is equal to x into 1. How? X into 1 plus y is equal to, that is x into 1. As per the rule, one rule is there, that is rule 2 is there, y plus 1 is equal to 1. I will show you this rule. We apply this rule, rule 2 apply. There you see x plus 1 is equal to 1. Okay, whatever the value of x, with add with 1, the value is 1. We have already proved through logic gates. So that rule also we apply here, that is y plus 1 or 1 plus y is equal to 1. Okay, like this you have to prove it. So now you see x into 1, so x into 1 means that is x. So now x plus xy is equal to x. That is proved. Okay, like this different also rule apply and proved as previous that is rule. Okay, now another rule, rule 10. Rule 10 is defined x plus x complement y is equal to x plus y. We define x plus x complement y is equal to x plus y. How to prove it? Now we prove it. Okay, how to prove it? You see, x plus x complement y. Okay, x plus x complement y means another way also we define, like instead of x. Okay, instead of x, you see here just before we also consider, okay, x plus xy is equal to x. In this case x also represent as x plus xy. So now instead of x, this x, we also consider x plus xy instead of x. Okay, plus x complement y. Now I think all of you understand. From LHS side, x plus x complement y, we have already discussed that x plus xy is equal to x. So instead of x we write that is x plus xy instead of x, then remaining x complement y is there. Okay. So now you see, now just elaborate that part, that is here x, here also we can write according to rule 9, here is rule 9. Okay. Now we see here x also expanded, x also can be expanded, like x instead of x, this x we write x into x, x into x is equal to x, there are no changes of that. That rule also we can apply, x dot x is equal to x. So other part also same, x y and plus x complement y, that is the rule 7. You can take that is rule 7 in this way. Okay. Here also write rule 7, see x dot x is equal to x, rule 7 we have already taken, so rule 7 here. Okay. Now we see another, here also x dot x we got it. Okay. And another is whenever you go through we have to expand it, because our aim to prove x plus y, so we have to expand accordingly. Okay. Now x dot x plus, okay, here is a xy plus x dot x complement plus x complement y according to rule 8, here rule 8 according to rule 8. Okay. I will show you the rule 8 is like this, because x dot x complement is 0. Okay. We go through rule 8. This rule also we apply. You can tell why we will go through this one, because our aim to prove that is x plus x complement y is equal to x plus y. We have to prove that. Since we have to prove, so we will collect different rules which are we have already proved. From that rule we collect and put here. Okay. Now we say x into x. Okay. Here we can also now common from these 2, here from 2, here also 2, x common, that is x plus y, plus here x complement common, x plus y. So now x plus y is common both. So x plus y, here x plus x complement. Okay. X plus x complement. We know that x plus x complement is equal to 1. We have already proved x plus x complement. We see that is what is rule. Here you see x plus x complement is 1. We have already proved. So x plus x complement is equal to 1. Okay. So here what happens? We can write x plus y into 1, since x plus x complement is equal to 1 as rule 6, as rule 6. Okay. X plus x complement is equal to 1. Now we see what is the result, x plus y. So prove it, x plus x complement y is equal to x plus y. That is proved. Okay. Like this different theorems or rules we have to apply, also we have to prove it as per this rule. Which rule we have already considered or already defined, those rules are just we apply and prove it. Okay. So this is the rule number 10. Next also we can use. Now we consider rule number, that is 11. Okay. 11 rule 11. Okay. rule 11 is defined x plus y, okay, x plus y into y plus z is equal to x plus yz. This is very it is very difficult, that is rule you have to remember, very simple also difficult. So we have to remember this rule. It is very useful in different places. I also use this particular rule. That is a very simple way. X plus y plus x plus z, sorry, it is x plus z, x plus y, here x plus z, okay, here actually x plus z, x plus y into x plus z, x plus yz. X is here, x is here, okay, x part plus yz. We have to remember, since both are first variable x, another variable yz, so x plus yz. We have to remember this part. Okay, x plus y dot x plus z is equal to x plus yz. Now similarly prove it. X plus let us x plus y into x plus z. Okay, so now apply the distributive law, very simple way. X into x plus x into z plus y into x plus y into z, okay, or x into y also we can also write. We can go through distributive law. Distributive law, we go through this one, okay. Then we see how next part, x into x, it's always x as per the rule, that is x into x is equal to x. We have already proved it, okay. X into x is equal to x. You see, x into x is equal to x. We have already proved x into x is equal to x. So x into x is a x. We can change it. We can't change it. X into x is a x. So next, x dot z plus yx, okay, or we can reverse cumulative also. We know that xy is equal to yx, xy plus yz, okay. So now we check it, and x is 1 plus z, x is common here, x plus y plus 1 plus z plus xy plus yz, okay. And another is, you know that 1 plus z is equal to 1. We have already know, okay, 1 plus z is equal to 1. You see, 1 plus x, 1 plus z, y plus 1 plus y, like this, it is 1. So z plus 1 is 1, 1 plus x is 1, like this. We can also use that rule, okay. So now x dot 1 plus xy plus yz, okay, as per the rule 2. Rule 2, we got it, okay. Now here what is the result? X plus xy plus yz, okay. Here again x also we can take common, 1 plus y plus yz, we can take in this one, okay. Here similarly y plus 1 plus y is equal to 1, we know that, okay. 1 plus y is equal to 1, as per this here 1 plus z is equal to 1, here we can write 1 plus z is equal to 1, okay, as per the rule 2. So in this way we can consider 1 plus y is equal to 1, that means x into 1 plus y plus z. Here x into 1 means x plus yz, okay. So x plus y into x plus z is equal to x plus yz, okay. X plus y plus x plus z is equal to x plus yz, okay. Now it is proved. Very simple way. Now it is proved. Okay. So this is the important rule. X plus y plus x plus z is equal to x plus yz. Very simple way. We have to remember whenever this rule is applied. Okay. Now another rule. Another rule is that is a important rule. 12th rule. De Morgan's. We can write De Morgan. Okay. De Morgan's theorem. We can write De Morgan's theorem. It is a very important theorem. Actually, it is a very important theorem. De Morgan's theorem. Okay. Now see how to prove it, or what is the concept of that. But you have to remember this particular theorem. Okay. Very simple way. That is a x y complement is equal to x complement plus y complement. We have to remember this one. Okay. X y complement is equal to x complement y complement. Otherwise, other way we can write just symbolically x plus x y complement is equal to x complement y complement. Okay. If we go through certain that is proveness truth table also we can use to prove it. Okay. That is also we can take it. Okay. So you see this De Morgan's theorem we apply in this way. Actually it has two rules. One is x y complement whole complement is equal to x complement plus y complement. It is one rule. Another rule also there, that is x plus y complement whole complement is equal to x complement dot y complement. Okay. In this way. So we have to remember very simple way. Suppose x y whole complement is equal to x complement plus y complement, or another is x plus y whole complement is equal to x complement dot y complement. Okay. We have to prove it that is using truth table. Okay. We have to prove it, the truth table. First one. Let us very simple way. Let us like we can draw different values. For example, very simple values you can also consider for first part. Okay. X y. Okay. You see now I will draw different part, and very easy to define that part. It is x part, it is y part, it is x complement, y complement, next xy, okay, next xy complement, okay, and here x complement plus y complement. We will see that. Okay, this x complement and y complement. You will see that is in this way you can also define. Very simple way we can take the different values. Okay. Now we see here same 0 0 1 1 0 1 0 1. Okay. X complement 1 1 0 0, y complement 1 0 1 0, because this is reverse part of that. Xy, this xy 0, it is also 0, it is also 0, it is 1. Xy complement means here is 1, here is 1, here is 1, here is 0. Here x complement y complement plus add, it is 1, it is 1 0 1 1 0 0 0. So both you see this part is true. Okay. That means the first theorem, De Morgan's theorem, is true. This part is true. Okay, this part is true. Next part we will see. Next part very simple way. Same thing, we just draw. Again we just extend this particular table, then we can find out very simple way. We can also take it. Okay. First part is here similarly x y, here is the x complement, y complement, next x y and x y whole complement. Okay. Next x plus y, another is x plus y complement. Okay, x plus y complement. Now take different values, 2, 3, 4. Okay, different values you can take it. 0, 0, 1, 1, 0, 1, 0, 1. Okay, x complement 1, 1, 0, 0, 1, 0, 1, 0, because 0, 1, 0, 1, 1, 0, 1, 0. xy it is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. xy complement just reverse of this, 1, 1, 1, 0. And x plus y it is 0, it is 1, 1, 0, 1, 1, 1, 1. And xy complement it is 1. Okay, it is a okay, it is a 1, it is 0, it is 0, it is 0. Okay, this one. And again another part also there, s complement and y complement product. Here also another line also we can put here. Here is a x complement dot y complement. Okay, x complement y complement means 1 1. Here is very simple way we can take. Here 1 1, it is 1, 1 0, sorry 1 0, it is 0, 0 1, 0, 0 0 0. So this part is equal to this part, because it is 1, it is 0 0, all are 0, you are 0, this is 1. So second part also true. Okay, so De Morgan's rule also true whenever you use different values of x and y in a different ways. Okay, when we consider different values x and y, then we prove it. De Morgan's theorem also true as per this rule, that is x y whole complement is equal to x complement plus y complement, and x plus y whole complement is equal to x complement dot y complement. This is true. Okay, so here question is whenever a large number of variables whenever we consider, then what is the result? For example, for a, again a part we will consider like a very simple way. Let us consider a, b, c, d, like this, different more number of variables will consider with a complement. Okay, then it is equivalent to, that is what, a complement, because xy whole complement is equal to x complement plus y complement. Similarly, a, b, c, d whole complement is some number of variables we can take it. A complement plus b complement plus c complement plus d complement plus whatever the number of variables we can take it, doesn't matter. Okay, that kind of things also we consider. Similarly b dash also. Here if we go through this one, same thing, a plus b plus c, okay, plus number of complement we consider, number of variables complement. Then how to define? Similarly here x plus y whole complement is equal to what? X complement dot y complement. Similarly we can consider, that is in this particular part, that is a complement dot b complement dot c complement dot like this, D, E, whatever the number of variables with the complement. Okay. So, De Morgan's theorem very important to solve different rules of Boolean algebra. If some complexity is there, some Boolean algebra having some complexity suppose there, it will solve by this De Morgan's theorem. It is very easy to solve. Okay. So, this is the basic concept I have already discussed in this way. Some concept also we defined this in this way. That is a very important part of this particular Boolean algebra. So, I took this Boolean algebra, that is 12 that is rules. So, I explained all things. I hope all of you understand. But another part is there, but not so much it is defined. But that is we can tell as a that is 13 rules also. Rule 13, that is a duality, actually duality also there, duality rule means this principle actually conversion of one to another. Okay, like a conversion of 1 to, we can consider duality concept, that is conversion 1 to 0 or 0 to 1, like this we will consider converted. Okay, convert like this, convert 1 to 0 or 0 to 1 in this way. Or sometimes we take OR gate, convert, we can take a convert OR gate to AND gate. Okay, or reverse, okay, or reverse, like this. Some duality rule also there, we can use that is conversion from one value to another value or one gate to another gate. Very simple way we define this or that is a duality rule. Okay. So, these are the that is rules under Boolean algebra. I hope all of you understand this Boolean algebra very simple way. It is defined and it is very useful also, not defined, it is very useful also, because you see whenever you go through this Boolean algebra with different rules, like rule 1, you see very simple way, I will just explain once again. Rule 1, x plus 0 is equal to x, I have already proved. Rule 2 is x plus 1 is equal to 1. Okay, very simple way. X dot 0 is equal to 0, because dot product once 0 means definitely it will create a 0, and x dot y 1 is equal to x, x plus x is equal to x. Okay, this rule I define, and this is the fifth rule, that was the fifth rule. Next is x plus x complement is equal to 1, x dot x is equal to x, x dot x complement is equal to 0. Okay, this rule I have already explained. Another is x ninth rule. Here what happens, we just prove through certain rule which is already proved, that is x plus xy is equal to x. Okay, x plus xy is equal to x, very simple way, because previously we have already discussed that part 1 plus y is equal to 1, 1 plus y, 1 plus x or x plus 1 is equal to 1. Applying that rule we prove it, that is x plus xy is equal to 1 x, because that is important rule which the with the help of rule 2, because y plus 1 or x plus 1 is equal to 2. Based on that we have to prove it. Okay. Another important part we have to remember this one, these two rule very important, three rule actually here very important for long processing of any kind of data or any kind of proveness. X plus x complement of y is equal to x plus y. You have to remember this part. How to prove, I have already proved, but we have to remember this part. Okay, x plus x complement of y is equal to x plus y. That is the important part. X part you see, remember x part, x and x part automatically deleted and y part is there. But we have already proved it. There is no problem for this. Okay. And another rule, important rule is there, that is here x plus y into x plus z is equal to x plus yz. Okay, another important part, x plus y into x plus z is equal to x plus yz. You see, x part is there, only yz it is multiplied, x plus yz. This we have to remember this part, because this rule is important for Boolean algebra. Whenever it is necessary, you have to use those rule for different purpose whenever it is necessary. Okay, those part we have to remember that part. And another important part is De Morgan's theorem, which is very important, because De Morgan's theorem is applied different application in Boolean algebra. We have to remember this part. Okay, so De Morgan's rule, x plus x y whole complement is equal to whole complement of x y is equal to x complement plus y complement, or a whole complement of x plus y is equal to x complement dot y complement. We have to remember this. Okay, and if a large number of variables, so we have to define accordingly. Okay, so these are the basic rules. I defined these basic rules in different ways. Okay, so I hope all of you understand these basic rules, and a rule for different rules for Boolean algebra with different ways. I hope all of you understand all rules. Okay, thanks to all. I hope all of you understand this topic. Okay, if you like this, please comment on my videos, and please subscribe my channel. Okay, thanks to all. Thanks to all visitors and auditors and all stakeholders. Okay, thanks to all.